What we're going to do is we're going to break this up into 90 degrees or pi over 2 increments. 0 to pi over 2, pi over 2 to pi, 3 pi over 2, and 2 pi. Similarly, going backwards, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. What I'm going to put up next is absolutely vital that you memorize these, and I don't really know any better way to do it than just write them down a bunch of times or do so many homework problems that you just get it in your memory. Surprisingly enough, too, I teach calculus 1 and 2 and upper division math. I run into people who don't know this when they really wish they would have. So I would take the time, and that is to just know that cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is negative 1, and the cosine of 3 pi over 2 is 0. And now begins the cycle again, because remember, we're really going around the circle. So cosine of 2 pi is equal to cosine 0 was 1, and it just keeps going on and on. Also, cosine is an even function. An even function is a function that f of minus x is equal to f of x. Basically, if you put a negative number inside here, it will kill it off. It will be the same value. And let me put this up over here, I guess. Cosine of minus x is equal to cosine x. I can show you a reasonable reason why this is true using the unit circle. You prove it in Cal 2. So what does that mean for these other values? And first, actually, let me put this up. I know, also cosine. So this is something you need to know. Cosine and sine vary between 1 and negative 1. They're never bigger than 1. They're never smaller than negative 1. So here is 1. Here is negative 1. Here is, cosine of 2 pi is 1. Let me see if I get my draw in hand here. 0, negative 1, 0, and 1. And now, so what's the cosine of minus pi over 2? Well, we already said this is an even function. Putting a minus in there isn't going to do anything. It's going to be the exact same. So this is going to be 0. By a similar argument, this is going to be negative 1, 0, and 1. And here is my most handsome representation of the cosine function on this interval. Too bad, not too bad. And it just keeps going on and on, okay? And what does this look like? This is a wave. So this is an extremely valuable. These functions are very, very valuable. Actually, the history of trigonometry and all the things that have come out of it are really amazing. And even a lot of things you don't actually use so much. Dentists take calculus. I don't think they use it much. A lot of people end up using some trigonometry. Surveyors, it shows up in a lot of weird places. It's good stuff. Okay, so this is some basic places in the cosine function that you absolutely want to memorize, and the sooner would be better. Your calculator knows these, but it would be better if these were in your mind. We're going to have to take a little break in a second, but I also want to figure out what sine is, and I'll point out to you that the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1. And once again, back to the circle, the sine of 2 pi is 0. We'll be right back after this message. Okay, so we're back. What I want to tell you about sine is that sine is an odd function. And what an odd function is, you'll remember an odd function is f of minus x is equal to minus f of x. It means that the negative sign kind of pulls out of it. And what is that going to mean? So I'll write this. Sine of negative x equals minus sine of x. What does that mean for these negative values? Well, so the sine of negative pi over 2 is going to be the negative of sine pi over 2, or negative 1. Similarly, the sine of pi is going to be the sine of negative pi, but 0 and negative 0 are the same. By a similar argument, we have this is 1 and this is 0, and now, oh, and I didn't put these in over here, so we have here, here, here. These are these values. These are very basic. You're actually going to have to memorize these and about twice this many more to really have a good handle on this. And now let me draw the sine wave. And you've probably heard the sine wave. You generally don't hear cosine wave, but it. Okay, and what do you see here? Let me label these. This is sine of x, and this is cosine of x. What hopefully is striking is that these look nearly identical. They're just offset by, well, how much? This one's 1 at 0, this one's 1 at 90 degrees. They're offset by 90 degrees. So these functions have something very deep in common, which we'll be getting to. Everything that's up on the board right now, you need to know. Sorry. The nice thing is that I'm going to show you a picture of the tangent function, probably next lecture series. And that one, you should be able to draw reasonably well. There's other trigonometric functions that it's good to know. It's okay to look stuff up. But these two in particular just show up all the time. How is the unit circle related to this, once again, for these other sines and cosines values? This is almost a good looking picture by my drawing standards. I'm going to leave it for a second. So here's the unit circle. We just stretched it out to infinity, but let's go back to the unit circle in our regular coordinate grid. What I would like to know is, what is the sine of pi over 4, or sine of 45 degrees? These are the same thing. It'd be good if you know what pi over 4 is, of course. Well, so let's think about this. Let's look at, so here's 90 degrees. If we split this, we have this line y equals x, right? And I'm going to go here. This is 1. This is 1. So here's this point. Okay. Here's our right triangle. You'll notice that this isn't the unit circle because of Pythagoras' theorem. Here x equals 1. Here's y equals 1. This is 1 squared plus 1 squared, which square root, which is equal to the square root of 2. This is by Pythagoras' theorem. I'm sure everybody knows it. This is what I mean by us not always using the unit circle. And as a matter of fact, when you get into calculus, sometimes it will not be handy to use a unit circle. And I want you to be able to deal with any circle. And I probably shouldn't have just put this around because that made it look worse. But now let us go with our definitions. And actually, I'm going to clean this up a little bit. Everybody knows why that's true. So here is the square root of 2. Remember, the sine of pi over 4 of 45 degrees is whatever y is divided by what the radius is, or the hypotenuse. In this case, it's the square root of 2. This is equal to 1 divided by the square root of 2. Before the days of calculators, they would not allow you to use irrational numbers in the denominator because it wasn't easy to compute. They would make you do this, square root of 2, square root of 2, and they wrote it as, so they would write this as the sine of 45 degrees is equal to the square root of 2 over 2. This is equal to 1 over the square root of 2. Are we in your classroom? Oh, okay. We have fans.